Hello everyone, in this video I want us to look at a few examples of how to add rational expressions. So the first one we're going to look at is 5 over 9x cubed plus 1 over 15x squared. Now, remember when you're adding and subtracting rational expressions, just like with any other fractions, you have to have common denominators. So the first thing we need to do is find the least common denominator, or the LCD, between 9x cubed and 15x squared. All right, so we are going to focus on the numbers first. So we're going to do the half box method of the numbers. So we're going to use 3. So 9 divided by 3 is 3. 15 divided by 3 leaves me 5. Use 3 again, that's 1 and 5. And now we can use 5. So we get 1 and 1. Okay, so then my LCD in this case is 3 times 3, or 3 squared times 5, which is 45. Now, number-wise, my LCD is 45, but remember, you also have to, when it comes to the variables, you have to take the highest number that you have. So we have an x cubed and an x squared. So then we need to take the highest one, so we need to take x cubed. So my LCD is 45x cubed. All right, so now that is going to become our new denominator. So here we're going to have 45x cubed on the bottom, plus we're going to have 45x cubed on the bottom. Now, we had 9x cubed, we went to 45x cubed. So how do we do that? Well, we multiply it by 5. All right. If we multiply the bottom by 5, we're also going to multiply the top by 5. And 5 times 5 on top leaves me with 25. Now to the one on the right, to go from 15x squared to 45x cubed, we multiply it by 3x. So then we multiply the top also by 3x. All right, doing that is going to give me 1 times 3x, which is 3x. Excuse me. All right, so now we have 25 over 45x cubed plus 3x over 45x cubed. They have the same denominators, so now we're ready to add these together. Once you have that same denominator, you can bring it over. So 45x cubed. Now the top says to do 25 plus 3x. Well, now we can't, because those aren't like terms, and I can't simplify it any further, and so then we are done. And there's our final answer. All right, very good. Let's try one more. So let's say we have 4x over x squared minus 9 plus x over x minus 3. All right. So now we see we have these larger polynomials on the bottom of our denominator. And so when we go to find our least common denominator, we first need to make sure each one is factored. So I'm going to factor this first one, difference of squares, so it becomes x plus 3, x minus 3. The second one is already factored, can't do anything with it. So we're ready to find the LCD. So to find the LCD, you start with your first one, your first denominator, and you write it down exactly how you see it. So x plus 3 and x minus 3. All right, now we go to our second one, which is x minus 3. Well, we already have x minus 3 up there in our common denominator, so we don't need to include it. Okay, so x plus 3, x minus 3 is our LCD. So now what we will do is we will take each one of these fractions, write equivalent fractions using that LCD. So for this first one, but it already had the LCD, least common denominator, so we actually aren't going to have to change it at all. So it's going to stay. Now when we come to the second one, we had the x minus 3 already with the x on top. What we have to do is say, okay, which one of our factors from our LCD were we missing? And if we look, we were missing the x plus 3. So we have to multiply the x plus 3 on the bottom, but we also have to multiply the x plus 3 to the top. All right, so now So on the left we have 4x over x plus 3, x minus 3, plus, I can distribute, x times x is x squared, x times 3 is 3x, over x plus 3, x minus 3. Now, since they have the same common denominator now, we can combine these. Remember, to add these rational expressions now, we are going to keep the denominator. So x plus 3, x minus 3, and we're going to combine the tops. So here we have 1x squared, so we're going to keep it. Then we have 4x plus 3x, which leaves me with 7x over that common denominator. And if we notice, I really can't simplify it any further than that. And so that will be our final answer. Again, it's all about making sure we use the right LCDs, getting those common denominators, and making equivalent fractions. All right, one more example of adding rational expressions. So let's say we have 3y plus 8 over y minus 7 plus 2y over 7 minus y. Now, if we look at these denominators, they are really, really close. They're really close. But they're not exactly the same. They're what we consider opposites. And so if we remember the way opposites simplify, if I have x minus a over a minus x, I know that that simplifies into -1. Okay? Well, I can use that fact, and I can get these denominators to be the same by simply taking this second fraction and multiplying -1 to the top and -1 to the bottom. And so what that's going to give me is the first one stays the same, 3y plus 8 over y minus 7 plus, well, now this becomes a -2y, and on the bottom it gives me the signs change. So it gives me my y minus 7. All right, so now we have common denominators. Okay, so now my denominators are the same, so we can take that y minus 7 and bring it over, and we can simply combine the tops. 3y plus -2y leaves me with just 1y, and then plus the 8. And again, we can't simplify this any further, and so we are done.